Hello. Yeah, we're gonna hello. Is everybody around yet?
Not yet.
All right. We have a couple of minutes to start. I'm gonna wait for maybe another 3, 4 minutes. All right. All righty. I think it's time for us to start our work now. Welcome back and good afternoon, everyone. I hope we're all doing great.
Yes, we are.
Yeah,
How
we're
about you?
today too. But as I told you, director is not here, but that doesn't mean we're not doing it. We're going to do it. Just that it's not, we may have some lapses, but at least we know we can achieve 70, at least 90% of our work. Okay. Oh, is everybody here? I have,
Yes, Professor, we are here.
see Ahmed. Okay, good one, Ahmed. Yesterday we spoke about high temperature sterilization, and today we're going the opposite way, low temperature sterilization. Okay, in healthcare. Anyone to remind us of anything like the last 2 points that we had at the end when we're summarizing our we spoke of two things that we're supposed to do in the end, like a conclusion. Can anyone remind us of that? In every sterilization, like your job in the at the SPD, what is the major two things that you are going to be doing? Following procedures carefully, and I know this one is going to tell us the same thing because it's also sterilization. You have to follow procedures carefully, okay? And then you have to also stay safe because we told you that we're dealing with heat, steam, 270 degrees. So you're supposed to know that you have to always think of your safety too. I told you at the point that going to the sterilizer, I try to stay like an arm's reach from it, which is maybe 1.5 feet or 2 feet, so that when you open it, the steam doesn't just pop up on your face. Okay? Those are things that they may not be mentioned directly in the book, but those are the kind of safety measures you should take when you go out there. Low temperature sterilization doesn't mean it's also going to be cold. We'll get to know more about it. It doesn't mean it's going to be cold because it doesn't say cold temperature. It just says low temperature. All right. So we have to put that at the back of our heads, that our minds, that it's not going to be cold. It just says low. Low doesn't mean cold. Okay. Does anyone has any questions about what we did yesterday? Not yet, right? All right. So this is what we're doing today. What I expect us to be able to get from this today is maybe to discuss basic requirements important for low temperature sterilization systems and to explain specific requirements for low temperature sterilization, which is going to be, we have at least three methods that we'll be looking at: the ethylene oxide, the hydrogen peroxide, and then ozone. We'll be looking at those three. So if you are asked three examples of or three methods of low temperature sterilization, it's ethylene oxide, hydrogen peroxide, and then ozone, okay? So we will review important parameters of the low temperature sterilization methods. And I've told you the methods are these three: the ethylene oxide, the hydrogen peroxide, and then the ozone. So, okay, so now the introduction here says introduction to low temperature sterilization, importance due to delicate heat and moisture sensitive devices. The importance of this low temperature sterilization is because there are instruments that are delicate and cannot take heat or moisture. They are sensitive to heat, which means that you can't put them through the 270 degrees, that excessive heat. They can't go through that. All right. And that's where the need comes for a low temperature sterilization. And the common methods, as I've told you, is the ethylene oxide, the hydrogen peroxide, and then the ozone. Okay. Safety training. Its technicians must be trained for safe and effective use of these methods, because you can't use something without knowing what to do in case there's a problem or how to stay safe during that process. And that's why we have to train you on that, understanding the toxicity and exposure levels, because all these things, hydrogen, even water can be dangerous. My friend once said, too much of everything is bad. So even food can be dangerous. Everything can be dangerous. So dealing with chemicals like these gases, they could be very dangerous. They could be toxic. So we should know what level of toxicity and exposure levels that we can take there and when we need to get out of it and when we need to report about it. Okay. And then the advantages and limitations of these methods. Each method has a specific benefit and drawbacks, which is the disadvantages. Professionals must know when and how to use each method. So you, as a central service professional going there, you should know when to use what. When to use the high temperature, which is, this thing is compatible with the high temperature. It can take the 270 degrees. This one needs low temperature because it cannot. It has heat sensitive instruments. You should know when to do that after all this training. The learning objectives here is to discuss basic requirements, which we're going to be doing as we go on, so that we can explain specific requirements for low temperature sterilization. And as I go, I'll be talking about some of them, just like telling you that, oh, some instruments are delicate, they are heat sensitive, they can take moisture. Okay, those are requirements. You know that if it's like that, then I have to go, my option is to go for the low um, temperature sterilization. The importance keeps explaining the importance to us. Essential for delicate, as I said, delicate, heat, and moisture sensitive medical devices. And which are, but it's not just the medical devices, but these are, we need the sterilization because they are used for surgical processes, and they are surgical instruments. That is the reason why we need the sterilization. It's not just any other thing. It could be any other instrument. If it's not surgical instrument, we don't have to worry ourselves about even sterilizing it. We could just clean it. It's not surgical. Whoever is using it is using it. But if it's surgical, as our case, our job demands that we serve that surgical operating room, then we have to make sure we are going to sterilize it before it goes there. So if it's heat sensitive, our other option is low temperature sterilization. And the common methods are here again. You can mix it, you can beat it anywhere, issue anytime. It's going to be mentioned over and over. So it's going to stick to your head. Even when you are sleeping and your child comes to wake you, Daddy, what are the three common methods of low temperature sterilization? You should be able to tell him ethylene oxide, which is written ETO, hydrogen peroxide, which is ACO. At times they write it H2O2. And then the ozone, which is represented by an O. Those science chemistry students will be able to explain it better to us. But I know we all understand the A2O2, and then the A2O2, and then the ETO as ethylene oxide, and then ozone as the O. Safety and training, as I said before, you need to be safe there. You need to understand the toxicity. Okay? So you don't have to take things for granted when you go there. You should know what level is expected. There are tables that will come up and tell you the levels. All right. So at the end, we'll discuss the requirements. So the basic requirements are coming here. The efficacy of various methods. We will talk about it. The safety of the method and the exposure monitoring. We have there's the ability to monitor sterilization process to ensure the sterilant is safe. Like it's not going to be a problem for you. What limits, we take the limits and know that, oh, this limit is still good for you to be around it. Okay? We're going to look at all that. The reliable monitor using physical, chemical, and then biological indicators, which you get to know when you go to the field. We have biological indicators that more like little bottles that we actually put in the instruments, and at the end we incubate to see whether they were positive or negative, whether the process was good. And we have the chemical ones that are like strips that we put in the trays, and then some are like tapes that we tape around the wrapped instruments. They are all indicators that we need to use. And then we will consider how these three methods, how the chemicals or the gases penetrate the instruments, because remember we need exposure before they can be sterilized. How do they penetrate and get the instruments exposed to them? The material compatibility, the adaptability, and then the approval. A lot of them, almost everything has to be approved before we can use it in there. So we're going to be looking at all that. Yeah. So now ethylene oxide sterilization, the background of it. It has been effective for over 60 years, used for heat and moisture sensitive instruments, especially medical devices. Okay. It has excellent microbial activity. Why do they say it's an has excellent microbial activity? Because it's able to kill the microorganisms effectively. If not, we will not be permitted to use it. All right. If not, we will not be permitted to use it. Something that will actually be coming up for us to look at will be like what they call the sterility assurance level. As we go, it's going to come up, and it's about the probability of a viable microorganism being present on the instrument after sterilization. Okay, So to come up, and that is what it's going to be. It stands for it's seen as the sterility assurance level, and it's like a measurement of the probability of a viable microorganism, a microorganism that did not die after the sterilization. Okay, what percentage were still left on the instrument? So it will pop up. When it pops up, we will have to we will understand it. Okay, so we see two words that come out here that has the aeration. Aeration, as we go, is just about the system blowing filtered air into the sterilizer during one of the phases of the sterilization process. But you see it is defined in the book, as you see. It's a process in which the sterilizer is subjected to moving air within it. Okay, which takes care of the residual gases or chemicals that will be on the instruments. And so it's good for us. Some instruments take a short time, some take a very long time. As we go, we see it, depending on which method was used. All right. The penetration, the efficacy, ETO's efficacy, which is ethylene oxide, says that it destroys cells' ability to metabolize or reproduce. So you see that before it kills it, it actually incapacitates it in a way, making it more handicapped, more vulnerable. It cannot metabolize and it cannot reproduce, and then it kills it. Some of the methods, as we go to the details, is going to tell you some of them use certain criteria to get in there, like use proteins and other things to do that. But then it's telling you it destroys the ability of the organism to metabolize or reproduce, and then eventually it kills it. The penetration capabilities of the ethylene oxide, it's from small molecules that vaporizes easily and then permeates or enters a wide range of materials. To permeate is to allow or to enter, okay? So it has that capability of entering a wide range of materials, going through them. Okay, sterilization cycle and process parameters are set, and they have all been standardized. So when you go there, that one is not going to be your job. It's there already. But if you're using this, the most important thing is the safety part that we're telling you to actually make sure you are safe around these machines, and the things that will be cropping up that you don't know as soon as possible. The way it works, we just introducing you to it so that as you look at the safety data sheets, you understand that, oh, this thing is like this, and I have to do this other thing in order to be safe around it. But then as of now, these machines have been engineered to be safe for workers. So we'll see all this, and the safety measures and material compatibility, we'll see it. A lot of this material compatibility is going to be based on the IFU or whatever the manufacturer has actually put down. Okay? Any questions up to this point? So the background of it, which you just need to know, is that it's been around for over 60 years, ethylene oxide, which means it's good to be around until this time. All right? And then we've told you heat sensitive stuff and those things. Yeah. ETO sterilizer, I don't think we have a very good image of it here, but they are just like normal the sterilizers that we see, but then their mode of working is what is a bit different. Because remember, they are using ethylene oxide instead of the steam that we looked at yesterday. Okay? So their mode of operation and within itself is going to be a bit different. But your job is going to use the parameters that is set down, put it in, load it properly. As we said yesterday, this side too, the loading is going to be your work. Make sure you load it properly and carefully. And then when you are offloading it too, properly and carefully, okay? So it says that it's been used over 60 years, suitable for heat and moisture sensitive medical devices. The development of sophisticated instruments now, remember, because of technology, new instruments are coming out more sophisticated. And that means some of them can't even take heat. So there is something that calls for this low temperature sterilization. The more these things are coming out, the more techniques that we will need to sterilize them. So as at now, ETO is good. It's been around for 60 years. It can take care of these complicated instruments that are coming out. But it's not only the ETO. Remember, we had two other methods, the hydrogen peroxide and then the ozone. But as of now, we're talking about the ETO. Any questions? You see this delicate, the image on the side, you see instruments there. These instruments are mostly like dental and eye instruments that are very delicate. So, and they cost a lot. So by the IFU standards, if they tell you this one is heat resistant, just make sure you put it in there in the low temperature, because when it breaks, it's a lot of money. And then just not the money of getting replacing it, but then what is going to be the fate of whoever or the patient who was actually like prepared to be there for the surgery, already prepped up. And the person is there waiting for this instrument, and then it comes out of the autoclave. It was in the wrong autoclave, it's damaged. So the patient may have to wait longer, or maybe the surgery has to be called off, which is very, very delicate, it's a critical situation. All right. So we have to be very careful with these things. That's what we see. The sterilizer image, I hope I'll get a better one for you. But as of now, we're going to be looking at what we have. The microbial activity of the ethylene oxide is here. It effectively destroys microorganisms. But what it targets the cell's ability to metabolize, as we said before, it's going to cut it off from reproducing. Okay, if it can reproduce, it means it can keep life going. So it cuts it off from reproduction. It doesn't reproduce, and then it's able to overpower it and kill it. Okay, the alkylation process, that's one of the processes that we'll be seeing. Then that's what this what is the ethylene oxide uses. Okay, it's 6 specific proteins, okay, in the microbe to actually react with it, and that's how it is able to overpower it. And that's the alkylation process by the ethylene oxide seeking specific proteins within that organism, that microorganism, and by attacking those proteins, it's able to overpower the microorganism, and in fact get it out of it or control it. So that is alkylation. You could see alkylation too. You could actually look. I think as we go, it's going to pop up in the book where it's going to be defined. But alkylation is about how the ethylene oxide, the process seeks specific proteins in the microbes to react with them. Okay. So by using that, it's able to overpower them and then kill them. So alkylation is something that we will have to define. We have to look in and define. But what I've told you is just how it works. As we go in, the book is going to give you the real definition of it. But in practical terms, or the easiest explanation will be the process by which the ethylene oxide actually uses the specific, like 6 specific proteins within the organism to attack and actually like get it not to be able to reproduce. And that way it's able to overpower it and kill it. Okay, that's the alkylation process. And we will see it's actually well defined in the book. But when you read it, that is just what you're going to get. That's going to be the practical explanation for it. All right. So that is what makes it effective. So we can't say that it's not effective. It's effective because it finds a way to attack the microorganism by attacking certain proteins in there and overpowering it, cutting off its reproductivity, and then it's able to overpower it and eliminate it. So now this one says sterilization cycle and process parameters. Okay, the ATO systems in healthcare. All right, this thing just popped up. We don't need it. Okay, gas provided in individual dose cartridges. That's going to be very practical when you go to the field. The ETO gas systems comes in individual cartridges, which with a dose in it, which goes into the machine. That one is just going to be there for you to use. But when you see it, it's going to be in a container. You see it. The cartridges placed inside the chambers of less than 10 cubic feet. Okay, the cartridge punctured under vacuum. So you are not going to puncture it. Once you place it in, the machine takes care of that. But the ETO is going to come in individual dose cartridges. All right. Leak management. Vacuum pulls room air into the chamber if a leak develops. So look at it this way. Just as we said in the decon, that the decontamination area always has a negative air pressure. That's the same thing that is happening here. So the air from there will not come out to harm you, but then if there's a leak, the vacuum is going to pull room air into the chamber if a leak develops. So that instead of the leak coming out and you getting exposed to the gas, it's rather going to be within because it's going to rather suck air from outside to go in. That's how the leak management in these ETO systems are, if it works right. Any questions? Okay, installation and ventilation requirements. ETO sterilizers should be in well-ventilated areas. That's if you become a manager, you need to position an ETO machine at your job. Consider that it must be in a well-ventilated area. As a professional, if you go and where it is, it's not well ventilated, you could ask your manager, why is it here? I don't think this place is well ventilated. And you explain whatever the ventilation is there and why it's there. But I know that under normal circumstance, it should be where there is good ventilation. Okay? Where there is good ventilation. That's one requirement. Room air exchange rate at least 10 changes per hour, which is the same as the decontamination area, where we said 10 changes per hour, which was like how many per minute? Per every hour is 60 minutes, right? And you need 10. So every 6 minutes, there should be an air exchange. Okay, just like the decontamination area. So that one should be something that you can remember all the time. Air exchanges is a lot of times on the test, but not from what I've seen was not from the ETO, but from the decontamination area. But remember, it's the same as the ETO now as we see. So if they tell you about room air exchange rate for the ETO and then the decon is the same. It's 10 changes per hour, which is every 6 minutes. Okay. It must be installed in negative pressure, which I just said. The decon is negative pressure. So that is something that you've learned already. So if you are positioning a sterilizer, which is ETO, wherever you placing it, it's not going to be in the decon. That one you should be, you should know that there is a no. We don't have sterilizers in the decon. It's not going to be there. But wherever you placing it, it should have a room exchange rate and also installed in negative pressure rooms. Okay, with contained ventilation systems. So rooms similar to the structure of the decon, whereby there's negative pressure there. All right. Can anyone tell us why there should be that negative pressure there around the ETO? Can anyone tell me why it should be like that? Anyone to help us with that? Why should it be like that? Tawfiq? Ahmad? Is Obin there? Gifty? Is Gifty around? Anyone can tell me why do you think it needs a place where ventilation is good or where there should be negative pressure? Why should it be that way?
To prevent microorganisms.
Okay, the microorganisms are going to be there, but how is it preventing them? We said that it's supposed to
So
keep
that
them within that area, right?
microorganism will remain in the same area, they will not go out.
Good one. That is exactly what I needed to hear. By having a negative pressure, it means that nothing leaves, no air leaves that room to another room or outside. Whenever there's a little opening, the air is rather going to come in, not to leave air from that side going outside. And that is because the microorganisms in there are not supposed to go outside. You all understand that?
Yes.
So when we say negative pressure, it means that room, whatever pressure is there, when opening the door, the air rather sucks in, it comes in, it doesn't go out. When there's any opening, the air rather comes in from outside. But the air in the room it's not allowed to escape outside. So that's why it says it's a negative pressure. It sucks it in. Are we okay with that? There are always questions on this negative pressure thing, especially from the decontamination room. And they will tell you to explain why you need that negative pressure. And but it's all about not allowing the microorganisms in that room or from the decontamination area to go out to contaminate other rooms. Okay. And the same thing with these ETO sterilizers. There are gases, so they don't want that gas to be exposed to other people by getting it out of that room, so that the system is made in such a way that when there's a leak, the gas doesn't come out, but rather the leak sucks in air from the room, but not letting the air from the ETO system to come out. That's why it has the negative pressure. Okay? So we say that it's good to install it in a negative pressure room with contained ventilation systems. All right. So most of the negative pressure rooms have outlets where the air can go through, but they are like sucked out. So that is going to be the job of your seniors, your supervisors and directors. But then that is how it's going to work. It's going to be designed. Periodic checks of ventilation systems, exhaust lines, and floor drains. Just as in the other side, we said the sterilizers must be checked periodically. And we spoke of how some have to be the drains have to be checked daily. Here he's telling you there must be periodic checks of ventilation systems, how the air gets out of that room, exhaust lines, and floor drains. All right, here they haven't put any time on it, but say that periodic checks. So based on which facility that you are in, if they do it once in a day or weekly, that is their business there. But then they will do it in a safe way. So that is not specific here, but I think wherever you go, however they're doing it, you also have to follow that. All right, so staying safe around this machine, the safety of it, the hazards and safety. The ETO is a toxic gas classified as a carcinogen and reproductive hazard. Okay, as a carcinogen, it means it's a cancer-causing agent. All right, when they say something is classified as a carcinogen, it's a cancer-causing agent. It's a cancer-causing agent, and it can affect reproductive. It can bring about reproductive hazard. You wouldn't want to be exposed to anything like that. Right? So you need to know that this is how this thing is. It's a carcinogen. It can bring about reproductive hazard. So you have to stay safe working with it. Okay. Engineering safeguards have been put in place actually to prevent this uh, these machines in a way that workers don't get exposed to all these carcinogens and those other hazards. So engineering has been, that's one of the mechanisms, is what I said, that when there's a leak, it rather sucks in the air from outside without allowing the air from inside to escape. Any questions up to this point? Any questions? Okay, so the next one says environmental controls protect the CS technicians. That's what we talk about, how the air exchanges and everything that they'll be doing in the room. It's all set up already and tested, and they keep testing it. So you don't have to worry too much about this. But when you notice any difference when you go, that's where you have to notify your supervisor or your immediate boss that I've noticed this. But they always have these constant checks. And also the system has been engineered in a way to prevent you, the personnel, from like getting exposed to all these carcinogens and reproductive hazards. All right? All right. So by understanding these hazards, you should know how to protect yourself around there. And then following, as we always talk about, the manufacturer has his own IFU that you can follow. Remember, the ETO manufacturer also or supplier also has an IFU. So in this case, try to make good use of the two. All right? Make good use of the two. Whoever made the sterilizer says, okay, this is what you should use on this machine. And whoever supplied the IFU to says this is the condition. So that if they are compatible, that's where we use it. But as I said, that is set already. Okay? But when you become a manager, you should be able to determine whether they are right or not. But as of now, someone is doing that for you. You don't have to worry too much about it. Okay, and you need to know the process procedures, storage and handling of the ETO gas cartridges, which you'll be told when you go there. Usually they are not stored just like anything. They are kept in very ventilated rooms that are very ventilated. Because remember, they are gas like cartridges, all right? But they have been organized in a way, engineered in a way that they are not easily like destroyed or to be perforated to leak out. Okay, we will see the other methods too. They all have cartridges that come, but they're all engineered in a way that assures your safety. Okay, but there are also safety sheets. Okay, that you will be looking at as we go on. We will be coming across all those things, and then the parameters for the sterilization. Any questions? And there are, you see the image to your right. There's something that someone is wearing like on his chest. It's like a badge. It's a device to monitor the exposure to ethylene oxide. Like when you're working around the system, it's supposed to be around your breathing space, like very close, not that far from your breathing space. So it should be able to take sample of the air that you're breathing in whilst you're working on this ETO machines. Okay, so those are the kind of devices that are there to protect you. It's attached to employees' clothing in the breathing zone, which is anywhere within the reach of your breath, like your nose, mouth. It should be around here. So you see where this one is hanging, right on the chest, like that. So it's supposed to take sample of whatever air you're breathing in at that point. All right. And then the test airborne ETO concentration. That is what this thing is supposed to do. By taking the sample, they could test the airborne ETO concentrations to see what level is in the room. If it goes beyond the level, the accepted level, they will have to either turn the machine off or call the specialist to come and the engineers to come and look at it. Any questions up to this point? The exposure monitoring, okay? Because there's a potential health risk. All right, so there's always long aeration times required for monitoring this. They always make sure that you'll be exposed. If you're exposed to it, we're supposed to get a sample, and by the end of the day or by the end of the sample period, they should be able to test it. So how exposed will you be? And that's what I'm assuring you that there are standards that are set by OSHA and other agencies, especially OSHA. For your OSHA is always on the employees trying to protect you against all these hazards. So OSHA has a lot to do here. And if you see the next bullet says the OSHA requirements, all right, system to alert employees in case of emergency. So the health system that you are working for should be able to alert you that, oh, there's a leak here, and we've read the samples, saying the samples are beyond where you should be. So no one should use this machine from now. They should alert you. You don't have to be seeking the answers. They should be looking for the answers for you. Okay? This includes leaks, spills, or equipment failure. So as soon as it happens, there must be an alert. There must be a notification notifying you that this machine is this, so no one should go near it. And that's some of the requirements of OSHA. OSHA requires that. When I say OSHA, I mean the Occupational Safety and Health Administration. All right? It has established permissible exposure limits, which they call the PEL, the permissible exposure limits. So if the limit is like 0.2, and then they go and read and see that, oh, we have our samples here saying 0.4, then there's a problem. They have to alert you that, look, it's not safe to be there. So these samples have to be taken regularly to actually ensure that we are safe. And that is a OSHA's requirement. They have to stay within the permissible exposure limits. Any questions? Okay, in the area monitoring too, they should be measured. They always measure ETO in working areas, okay, to identify potential problems. That is the work of the health system itself. You are not going to be doing that, but you need to know that there's something like that because there's a requirement. So they have to always monitor the area to make sure that the permissible exposure limits are within. We are not going to go beyond it. If there's any problem, we have to alert our employees right away. So just be on your guard. When you see notices, you read them. When you go to an autoclave and there's a notice placed on it, please read it. Don't just look at it and go. That is where they may place those notices. That's where they may place those alerts. If they have emails, some of us don't even look at our job emails. You have to look at it for such alerts in case you guys are using ETO in your facility. So any notice that you see on the notice boards, try and read it. Pay attention to those things because they could be serious alerts. All right, any questions? They also have leak detection tests, even though you may not see, because a lot of gases, you may not see them leak, but we have leak detection tests that will actually identify the leak. And then they refer to regulations to see, what is the permissible level here? Oh, this leak is raising the level to this point, so we have to do this. All right, so they follow the regulations. Any questions? This is mostly not going to be your job, but you have to know it because you have to be safe. And you have to be able to read all the alerts and understand them and relate to them and keep yourself safe and your colleagues. Any questions? Okay, so the materials compatibility. You cannot cook something like coming home. You cannot cook something like you take an egg and say you want to cook the egg. You just want to put it, you're not going to crack it, you're just going to put it in the bowl, just egg like that, not cracked, and put it with no water and put it on the gas, on the stove to boil it. What is going to happen? Is it going to boil? It's not going to boil. The woman should let us know. It's never going to boil because there's no water there. You need water in there to boil this egg. And then you put it in a pan, which was good. But the point is, you didn't finish it. Something was missing. And then another case to somebody who would like to go put a basket somewhere saying that, okay, I'm putting a basket on fire to fill it with water. Is it a compatible thing to boil water with a basket? No. It's not going to happen. Okay, so we always have to look at the materials compatibility with whatever method we're going to use. ETO is a very good one when it comes to materials. It's compatible with most materials in single-use and reusable medical devices. It's very compatible with them. But you have to follow the manufacturer's recommendations for each specific item. It's good for a lot of them, but then your choice there should be following the manufacturer's recommendations. Items not suitable for ETO sterilization include liquids, which can produce harmful chemical byproducts, and then devices with energy sources. Risk of spark, like batteries, the risk of sparking during a sterilization cycle. Leather items, chemicals in tanning process can form harmful, like the chemicals that will come out of, like the byproduct that will come out of it is going to be very toxic. And that is what it's all about. So 3 things that cannot be in the ETO sterilization are liquids, devices with energy sources, and then leather items. Do you all get that? But we know that ETO is very compatible with most of the materials in single-use and reusable medical devices. But then these 3 things are not suitable. Liquids, devices with energy, such as batteries, and leather items. I think this is straightforward. Any questions? Mr. Oteng, any questions?
No, sir.
Okay, good. I hope everything is going on as planned, right? So we see that the material compatibility, it looks like the ETO is very good, even though it's a gas that we may hate, but it's very compatible with a lot of our devices. Okay. So the packaging, standards for packaging, these are all going to be set out for you. But you have to follow the standards for packaging the products. So that you see most of your job is going to be like paying attention to standards, regulations, all right? Wherever you go, there's going to be a culture there. This is how we do it, and this is what we use. Follow those standards there. There are a lot of alerts on the walls, a lot of instructions on the walls, a lot of notices on the walls. Your first week should be like trying to get access to all these notice boards to see how they look and what they have on, so that when there are new ones, you could see it. You could notice, oh, there's a new alert here. Let me go check it. Okay? Those are something that you have to look at. And you will learn a lot from these boards. You see some devices with their images on how they are processed right there on the boards. Any new device that comes at times, the IFU comes with illustrations on how to prepare it, how to arrange it, the names of the parts, and how to sterilize it, the temperature and everything. So that you see, if you pay attention to those details, your work will be simplified. You will be training yourself without anybody telling you anything. Okay? So now it comes down to tell you more about the compatible materials to be used. Paper or plastic or TVEC peel pouches. When you go we have peel pouches. I don't have some at home to show you. We have peel, they are like envelopes, right? They're like envelopes in different sizes, but one side is more like plastic and one side is more like paper. But there is a special material that is heat resistant. And then with the low temperature ones, they don't take too much heat, but they are good for low temperature. But they look like plastic on one side and paper on one side. But we call them the TVEC peel pouches. The TVEC peel pouches. Okay? All right. So they look like paper plastic. And that is what I was telling you yesterday, that even in this low temperature sterilization, you're going to position them in the sterilizer like books in the library, in the bookshelf. Okay? The paper side and then the plastic side. So the next one comes again, the paper side of the next one is going to come next to the plastic side of the other one. That's how you arrange it, the same order, like that. So that you don't put two plastic sides facing each other. No, the paper side must face the plastic side of the other pouch. All right, but in the bookshelf style. Alrighty, that's just a reminder. So we have approved fabric wrappers, which you don't have to worry about. You will go and they'll be ready there in different sizes. Okay, and then we have the medical crepe paper. You don't have to worry about it. They'll be there. You don't have to get it. Polypropylene. This is just to tell you, in case there's a question, telling you like list maybe material that are compatible with ETO sterilization. You should be able to list some of this. And I think the easiest thing would be the paper, plastic, or TVEC peel pouches, which is one of the answers that always comes up. The TVEC peel. Some say TIVEC, and I say TVEC. Yeah, the peel pouches. Okay, it's very compatible with the ETO. Okay, and then most container systems. And when you go to the hospital, the facility, you're going to see a lot of our canisters. We call them canisters, and they have other containers too from different materials. So the ETO sterilizer takes most of these container systems. Things that are incompatible with the Winox foil, the Winix foil. It's very technical, but it's a foil, as you see. But even our microwaves at home, they don't take foils, right? Even our microwaves don't take foil. So you see that foil is going to be a problem in a low temperature sterilization process. But this is what they have put in the Winox foil. I've not come across it. I've not seen one myself because we don't use the ETO at my facility. But that is something, in case you see it at where you're going, it's a no-no for ETO sterilization. But I know that wherever they have it, the only time you may come across it is if your company uses both the ETO and some other sterilizer. If they don't use other sterilizers that take that foil, then you don't need to have it around you. Okay? Any questions? Okay. So the loading and unloading ethylene oxide sterilizers is nothing new. But all you have to have in your head is that I have to load it properly and I have to unload it properly. The different thing that will come up here will be the aeration process, where air goes in through, where we leave it to be exposed to air, for air to go, warm air to circulate, to remove the residuals. That's going to be the only difference. Proper loading. Avoid overloading to ensure effective sterilization. You know that already. Arrange items to avoid contact with chamber walls. This one, I think we didn't say, but we spoke about overloading. If you don't overload, there's no way your instruments are going to touch the walls. But if you overload, then you maybe force your instruments to touch the walls of the inner the chamber, the inner wall of the chamber. Avoid it. Make sure your instruments don't touch the inner walls. Some other clays have been designed such that when you pack the things in there, you load it, they're not going to touch the walls anyway, because there are certain points there that they will touch and they will not touch the walls. That if it's not like that, just make sure your instruments are not touching the walls in the autoclave, okay? So place pouches on edge in wire baskets. The pouches are the envelope type that I told you. They should be on edge, like you putting books in the library shelf, the bookshelf in the library. They should be on the edge like that. So the plastic side should face the paper side of the next pouch. Okay? Is that understood?
Yeah.
Good. Because that's something you have to do, or else they will come compacted that you can't even separate them. And if you want the sterilization to be good, that is how it has to be. The paper side of the next one should face the plastic side of the other one. And that way you arrange it like the bookshelf style, you should be good. That's what they're referring to as the edge in wire basket. We have wire baskets that we use so that if your sterilizer is like the big ones, definitely your pouches will have to go into those wire baskets because they don't have shelves that will contain your pouches. So you arrange them in the order that I've told you, like in a book tray. You arrange them like that, paper to the plastic, paper to plastic, like that. Arrange them nicely so that the basket is what you're going to put in the autoclave. All right? It's not a big thing. When you go there, you see it and you understand. You see those baskets all over, but they are used for those things, like pouches. You may have a lot of pouches to sterilize. So by organizing it that way, it makes it easier. All right. So the aeration process is necessary to remove residual gases, because when you finish with the ETO, it is assumed that the instruments coming out have some gases still on them. Okay, so during the end of the process, the aeration process comes in during the end of the cycle, which ensures safety for you, the healthcare worker, and the patient, and the procedures that they're going to do, so that nobody's going to touch these things with the residue on them. The aeration process is going to take, it's like blowing air on something. Like, okay, you sandpaper, you try to clean the surface of a wooden plank with a sandpaper or a brush. Okay, after brushing it hard, you need to maybe use air to blow the dust off. It's similar to aeration. Okay, this time, even though your eyes don't see the gases, the aeration, the air is going to blow those gases, those residual gases off the instrument or the canister or the wrapped package. Are we all okay with that?
Yeah.
Okay. So the next one is the vacuum pulses remove ETO from the chamber. Remember the system is coming to an end. So now after the aeration, the vacuum pulses remove the ETO gas in the system. It's removed out. Then warm air goes in there, circulates to remove the residuals from the instruments. And that's where that's how the aeration process goes. As soon as the ETO is vacuumed out, then the warm air comes in. Why does warm air go in and not cold air? Who can tell me? Why is it warm air but not cold air? Why is it warm air going in but not cold air? Who can tell me? Is Amina here? Why is it warm? Is Shania here? I know 27 people are around, so you should tell me. Somebody should tell me. Why is it warm air going in to circulate instead of maybe cold air? Remember I mentioned condensation yesterday, right? And I told you that even when you take I've told you certain things this morning, that low temperature doesn't mean it's cold temperature. I said low temperature. Doesn't mean cold temperature. Okay? And so you cannot pump cold air in there because it's not cold in there. It's warm in there. It's not as hot as the 260, 270 that we use in the steam, but it's not cold in here. Okay? And so you cannot pump cold air in there because there's going to be condensation in there. All right? So warm water circulates to remove the residuals from the instruments. The general recommendation for the aeration process is 8 hours at 140 degrees Fahrenheit. You see that is not cold, right? Even when we're walking outside and the outside temperature is 100 degrees, how do we feel? Summertime, 100 degrees, how do we feel?
Hot.
Very, very hot, right? I remember one of the stations, one summer day, they asked a little girl, what do you think the temperature is? I said, this is more than 1,000 degrees. She was burning up. Okay. And that was just like 100. That day was just like 100 or 102, which was crazy for everybody. So imagine 140 degrees. So the low temperature doesn't mean cold. And this is just what I wanted to explain to you. It doesn't mean cold sterilization. It says low temperature. And the low here, you see, under 140, with 140 degrees Fahrenheit, aeration should take, it's recommended that aeration should take 8 hours at 140 degrees Fahrenheit. And that is not cold, but then it's low compared to steam. All right? But then the aeration rate depends on the material nature. So maybe some will be more than 8 hours, some will be less than 8 hours. But the general recommended one is 8 hours. Any questions? Any questions?
No.
All right, let's go. Sterilizer performance monitors. You see them, there are physical monitors, you see them, there are chemical monitoring and biological monitoring too. So the physical monitors include operating pressure gauges, which I told you in the steam. I showed you, there was an image of a sterilizer with the dashboard, the digital screen, where you see the temperature. This one's too, you're going to see the temperature. Because remember, I told you, even if it's cold, there's supposed to be a temperature limit. But this one is not even cold. It's just low temperature, but not cold. So the dashboard or the screen that you see on the autoclaves or the sterilizers is going to say, it's going to include operating pressure gauges. What is the pressure in there? What is the humidity in there? What is the temperature in there? And then the control. Okay. So that is what you're going to be seeing. The charts, tapes, and graphs detailing measurements must be examined before removing the instrument. And the tapes was what I told you that yesterday we saw an image with tape on the instrument. That was, I said, before it goes in the autoclave, it could be gray and blue. And then when it comes out, the gray spot will be black, meaning, yeah, it's good, it's sterilized. All right. That's one of the physical monitors. And some are graphs detailing the measurements on the screen. Okay. You have to examine all those. At the job, they'll tell you when this it's like this is gray. When it goes in, it's supposed to come this way. Okay, this chart's supposed to read like this. They'll show you all that. At my point, we use the tapes and then we use the paper strips too that goes into the instruments, the canisters. All right. So the tape is one measure. When you take the wrap out and the tape doesn't show that it was well sterilized, the tapes will not be well conditioned, so that the color will not be as you're supposed to see. The tape manufacturer has its eye if you tell you, look, if you use it right, the gray colors should turn black. So if you take it and the gray color didn't turn black, but it's yellowish, it means something was wrong. Okay, those are kind of some of the physical monitors that you'll be seeing, and then the charts on the walls, everything is going to be, we have them there, they are monitors, because this is a situation that everything has been measured. The chemical monitoring too is there, where we have those paper strips and the indicators that we put in the instruments. We put them in the hard to reach areas to make sure there's real penetration to get it totally conditioned to come out past. Because we look at it and the IFU tells you, okay, this indicator must change all through. Maybe it's like 3 inches long with that strip on it. If it changes 2 inches and the tip is still not changed to the color specified by the IFU, it's not correct. It's not right. It didn't do it right. Something has to be done again. Okay? So if they take that instrument to the OR and open it, and that indicator was partially cooked or didn't reach the limit as per the IFU, they have to return the instrument. So that's one of the chemical monitoring. It's external chemical indicators should be used on the outside of every instrument package. So you see that tape that was on it, okay? If they look at it, it could tell them something, good or bad. It has to be used. And then we have the biological indicators. The chemical one, it tells you internal chemical indicators should be used inside every pack, which is the paper strips that I was talking about, especially the peel pouches, which is the envelope type that contain one instrument each. Each one is going to have one of those indicators, one of those paper strips that is supposed to change color but when it comes out of the autoclave. All right, that's an internal chemical indicator. All right, and the tape is an external one because that one we place it outside the package. Any questions? You see this as you go to the place, and I know by the time you go for your clinicals, we'll lay hands on these things for you to see them practically. Then the biological monitoring, we have biological indicators that have live microorganisms in them. So we usually, like at my end, we use it for delicate instruments like the critical instruments. Dr. Pimpe and Professor John have told you about these classes of instruments. Some instruments that we use for critical surgeries and stuff, when each time we cooking or processing them, sterilizing them, we put biological indicators in there. Okay? We put it in the autoclave, and then we have the chemical indicators in the canisters too. So you see how many things we're using to make sure this thing comes out right. And after the biological comes out, we have to incubate it to make sure the microorganisms in the biological indicator were all killed. That way we know the thing has come out sterile. Okay, so you see the kind of performance monitors. We have physical monitors, we have chemical monitors, and we have biological monitors. A lot of times it's going to be on the test. Kind of monitors that we have, sterilizer performance monitors. We have physical, we have chemical, and we have biological. You see them. The physical ones are mostly like the charts, the charts and the display boards that we see. The chemical ones are the tapes, which are put externally, and then the paper strips that are put in the canisters. And then the biological are the live microorganisms in bottles, like completely sealed little tiny bottles that go with the cooking. And when they come out, we incubate them to make sure they are well sterilized before we release those instruments. And that's why we see that most of them, the microorganism of choice for these biological indicators is the Bacillus atrophius. That one is going to be something that they will ask you on the test. The microorganism of choice. You see how that sentence is? If you like, write it somewhere. The microorganism of choice in the biological monitoring is the Bacillus atrophius spore. And we told you spores are very difficult to kill, right? Very difficult to eliminate. So after it comes out of the incubator of the autoclave, we have to put this on the incubator to incubate it. I think for the ETO, it may be like 24 minutes or so to incubate the BI. The biological indicators, we call them BI there. So to incubate that BI or biological indicator, which has these spores, at times it takes like 24 minutes. So you just go sit it on, you crack it. We have a way to crack it where the inner container of the bottle cracks, and then you sit it on the incubator. It times it out itself. You do the necessary documentation. It times it out. It cooks it, and after the required minutes, it's going to give you a negative or positive result. Based on that result, you can release the instruments for OR. If not, you have to reprocess that instrument. Any questions? So you see that with the ETO, every cycle in the ETO has to go with a biological monitoring device. which is the BI. So the ETO, you have to be very careful with it and have to do that. Even without the ETO, other low temperature sterilization, some systems, some facilities, make sure you add BI all the time. Okay? To be very sure that they're getting what they want. They're getting the sterility that they need. Any questions? Okay. So now the second one is the hydrogen peroxide systems. We said there were three, right? The ethylene oxide, hydrogen peroxide, and then the ozone. Okay, now we're doing the hydrogen peroxide. It's a gas plasma. The background is that oxidative process. We said the first one used what? Alkylation, whereby it attacks some proteins in the microorganism, cut off their reproductive powers or strengths, and then overpower them. By attacking those proteins, they're able to overpower the microorganism. That's the alkylation. Now we say that we are using hydrogen peroxide, and what it uses is oxidative process, which has been cleared by the FDA. Okay? That's the oxidative process. Anybody to tell us something about the oxidative process? It's more about adding oxygen or taking out hydrogen. It's a process that involves like adding oxygen or taking out hydrogen. And that's how this system works to overpower the microorganisms. Okay? The system has been cleared by the FDA. It's safer and faster than the ethylene oxide. Is that not good news? It's safer and faster than the ethylene oxide. And I think that's what actually my facility uses. We use hydrogen peroxide systems there, where the sterile machine, it has some cartridges, cassettes, they call it cassettes, that we put it in and the machine disperses it within itself. You don't have to do anything else apart from inserting the cassette and then using the circle. Which standard do you want? You want the standard circle, you want the, we have so many circles on it, about 3 different circles on it, okay? We have the flex, we have the standard, and you just press, and then we have the express. So all you do is, if you put this cassette in there, when it's out of cassette, it's going to tell you. So you have to put in the cassette. So you put the cassette in, you prepare the instrument, put it in with the necessary BIs and chemical indicators, and then select the cycle that you want. It goes on working. So you see that it's not even as crazy or detailed as touching the getting exposed to the gases. It's not easy to get exposed to the gases. They are engineered in a way that is very safe to operate in. Okay, even though I keep cautioning you that your safety is in your hands, it's still very, very safe to actually stay and to use it. Any questions at this point? Any questions? We got a few minutes to go for break. Any questions at this point? If no questions, then I'm going to continue. Any questions? All right. So the hydrogen peroxide, as they just said right now, says that it's safer and faster than the ethylene oxide, which is good news. For me, it's very good news, right? So this system uses the hydrogen peroxide as the sterilant, and the process that it uses is the oxidative process, right? So it talks about it's safe and has rapid cycles as compared to the ETO, and the byproducts are not toxic. The byproducts of hydrogen peroxide are not toxic, okay? But it's a very highly effective sterilant that sterilizes by oxidation of key cellular components. Okay? So it tells you that the penetration and the efficacy of it uses deep vacuums and multiple pulse additions, effective for a wide range of instruments. Guidelines for lumen, which is the instrument with cannulas in there, with channels in them. Those are the instruments that we call lumens. The diameter and length, there are standards for them. There are certain diameters that you can put in there. So there are standards. So a lot of times you'll be going with the IFUs, but then it has penetration efficacy such that it's able to go with a wide range of instruments. Okay, the types of hydrogen peroxide gas plasma systems. There are types, but basically it's not your choice at the facility. So whatever type you meet there, follow the IFU and ask questions and get used to those machines and operate them according to the IFUs. All right. Try to stay safe and try to do your work as you're supposed to. The phase of the hydrogen peroxide gas plasma will go through that, and then the safety measures. So exposure monitoring and materials compatibility is good. We're going to talk about all that. Does anyone has a question now? So plasma that I'm talking of is just a state of matter distinguishable from a solid. I think even blood, when they take blood out, you have the blood plasma, right? So the definition that is just giving you a scientific definition, that is just a state of matter distinguishable from a solid. So it's not solid, liquid, or gas. All right? Gas plasmas are highly ionized gases. Okay? Using a hydrogen peroxide solution ranging from 59 to 95%, and that's the kind that they use in the, remember, Professor John told you about this hydrogen peroxide thing and how effective it is when it has certain percentage of water in it. In this machine, it requires the 59 to 95% hydrogen for the sterilization cycle, okay? And it's been tested and proved that it's effective at killing microorganisms. Any questions? We're talking about the penetration. It uses these vacuums, as it has been mentioned up there. And there are guidelines that have been developed to actually treat or handle cannulas or lumens, instruments with channels through them. There are standards that you have to use. And then the types of the peroxide, the hydrogen peroxide, which I said, it's not going to be your job. Whatever system you meet there is what you're going to use. But we are telling you that there's this hydrogen peroxide systems there that you'll be using. The cycle and process involves vacuum, where there's heating, and then the injection, which is the second stage, where there's a pump of hydrogen peroxide into the vaporizer. Okay, and then the diffusion, which is more similar to the penetration in the steam sterilization. The diffusion in the low temperature hydrogen peroxide is more like the penetration in the steam sterilization. So the plasma, that as we define, there's a vacuum that decreases the pressure, okay, and radio frequency energy. Okay, it's radiated within the chamber from the electrode screen. When you go to like the sterile machine, when you open it, it tells you the electrodes may be hot. And the electrodes are not any complicated stuff. They are more like, how should I define it? They are more like some basket stuff in there, like some woven metal in there. But it always cautions you that when you open it, that those electrodes may be hot. So be careful unloading the stuff. So this is one of the things that it uses, that the RF energy ionizes the hydrogen peroxide, creating hydrogen peroxide gas plasma. Okay, the injection and plasma phases are repeated a second time. That is after the diffusion, after the exposure. Right, then there's a vent. So you have 5 stages, which is the vacuum, the injection, the diffusion, the plasma, and then the vent. This one requires no aeration because the byproduct is water, vapor, and oxygen. So you don't need aeration in this. All right. Any questions? I think I've taken care of all this asset now. It's used in low temperatures. It inactivates microorganisms quickly. Byproducts are non-toxic. No need for lengthy aeration. Okay. Any questions? The penetration, I've told you about it, that the diffusion stage is what is the penetration. And how effective is it? It's very effective because it uses deep vacuums and multiple pulse additions of sterilant. It increases the concentrations for effective sterilization and has a wide range of instruments, single channel, flexible endoscopes, cameras, which are some of the heat sensitive devices that we use in this. With that, we use the low temperature to sterilize. There are guidelines for the lumens, as I said already. All right. Various cycle parameters are considered, and there are newer generations, but it has its own restrictions and recommendations. Like the one that we use at my facility, we make sure the instruments are well dried before they go in there. Even though the system will be removing water from the instruments, we make sure they are super dry, well dried. Okay, well dried. The camera should be well dried before going in there. And that is one thing that has always helped us to get our perfect results from there, coming out positive, like negative of these things, of any microorganism, staying sterile, like the sterilant working and staying sterile. So when we dry it that way, our sterility is assured. The system works good, and then we get the right result that we want from the hydrogen peroxide system. The variety of peroxide, that's what I said. You don't need it that much because you are not going to be doing that. But then the compass system, they have compass systems that the cycles of which are about 28 to 38 minutes. The one at my job is between 45 and 50 minutes. Once in a while, like if depending on the amount of load in it, even if it's not overloaded and it's up to its capacity, at times it goes to 52 minutes or 53 minutes. Yeah. But then ideally it's between 45 and 50 minutes. So it's within range. The large capacity systems, as per this book, says that 75-minute cycle times. The different models, varying cycle times. As I told you, we have the flex on the machine that I use. We have the flex, we have the standard, and we have the express. Okay, so depending on what you go and meet, and then different load capacities. Well, mine, the one that I use here, the Starad 100, it has just 2 levels in there. So even if I have like endoscopes, maybe I just put 2 at a time. But there are times I just cook 1 in there at a time. Okay, depending on how the pace of work and how much pressure you'll be under. But that is how it is. And we have those various cycles that I've told you, and then the capabilities for processing what instruments. Any questions? Any questions? No questions? All right. Sterilization cycle process parameters. I've spoken about all this to you already. The vacuum phase load is heated to remove remaining water. Air is removed until pressure is below atmospheric injection phase. Atmospheric pressure. The atmospheric pressure, I told you about it yesterday, that the literal definition is how much pressure the atmosphere or the skies exerts on a unit of space. Like it's measured, they have several measurements for it. They have ATM, they have inch, PSI, depending on what book you use, but it doesn't matter too much to you. But that is how it is. So this machine, it does air removal, like to make sure the pressure within the system, within the chamber, is below atmospheric pressure. Usually they say that by they put it as 14.2 or 14.7 at sea level. But originally, when they talk about it, they rather want to equate it to a 0 when they actually using it in our terms. But that is technical for those who want to use those numbers. But we are good with whatever our machines are set up for. Okay? So the injection phase, concentrated hydrogen peroxide is pumped and vaporized. And then the diffusion phase, hydrogen peroxide vapor penetrates small crevices, which are the hard to reach areas of the instruments and lumens. And then the chamber returns to atmospheric pressure. You see, after the exposure, after the penetration. All right. Then the plasma phase, where the vacuum decreases pressure, and the radioactive, it says that they use the radio frequency energy ionizes hydrogen peroxide, creating gas plasma. And then the vent phase is where these things are all exhausted. Any questions? With the safety, it's more practical. Our time is up for a break. So I think we're going to take a 15 break now. This is 4:15, right? So we're going to take a 15 minutes break. And then when we come back, we continue from this slide number 21. Is that okay with us?
Yeah. Okay.
Okay.
Yes, sir.
Take a break.
All right, thank you.
Hello, are we all back?
Yeah.
All righty. Are we ready to continue? All right. So far, so good, because this has been more of a revision for you guys. I think Dr. Mike and Professor John have exhausted a lot about sterilization. So most of the things from now on is going to be more revision. Just little technical things will come in, and then wherever we mention as possible questions, just take notes. That way, by the time you go there, you're not going to get them directly, but it's just that idea and the answer. So you should be fine. All right? So take note of those little things that we'll be highlighting. Most of everything from now is going to be revision, because our job is all about the decontamination. You cleaning, decontamination, preparing it, packaging it, getting it sterilized to the OR, like safe transportation. The storage is even not a big deal, because if you follow all the stages nicely to the preparation and then wrapping and sterilization, saving it, there are ready-made carts there that you save it on for storage. It's not a big deal of anything. Mostly you will be more involved in the decon, getting it clean, getting it into the clean side, assembling it. That's where you're going to be more hands-on and very critical, okay? So now we're talking about the safety of the hydrogen peroxide. You know, the hydrogen peroxide, like other sterilants, it can irritate your eyes, your skin, your nose, okay? And that is why we always try to stay safe. And then it has been engineered in a way that you will not be exposed easily to it. But those are the kind of things. Being exposed to it can also give you throat issues, lung issues, and stuff. So always use your PPEs and be careful whilst you're there. Think of your safety, think of everybody's safety. All right? So it is there, but then we have the good side of it. That is a good sterilant. It takes shorter time compared to the ETO. So it's good for us to use. It comes in a sealed cassette, as I was telling you. The image that you see on the slide is the cassette is within that wrap. You see, and that you see that yellow line on it. In case there's an exposure where there's a leakage, that yellow line will change from yellow or white to red. You see that yellow line on the package?
Yes.
The cassette is within it. It's a plastic cassette with several slots of hydrogen in there. It's been made into little like straight little rectangular packs on that cassette, about 20 or 24 of them. So once you push it in to you feed it to the sterilizer, it tells you, just gets to a little way, and then it tells you it has received it, it's detecting it. You don't do anything again. It's pushes it, it sucks it in by itself, and does everything and places it where it's supposed to place it. And the only time it's actually pushes it out is when it's done, it's exhausted. Then it falls into a bin where you can take it out, and it's going to tell you we need a new cassette. So you have to empty that bin and then put in new ones. So you see that it's so engineered that you will not be easily exposed to it. But the most important thing that the book is going to tell you, and that I'm also going to emphasize, is that always have your gloves on. That's why I said the PPE. You can't go there wearing the gloves without wearing the PPE, without even gloves on your hand, thinking that only the scrubs and the other facial thing is what you need. No, your hands too. The gloves, because you're going to be touching this cassette if it tells you to change it, to empty the container. All right? And it tells you have to wear the latex, vinyl, or nitrile gloves, which are readily available over there. All right. So the hazards of hydrogen peroxide, it can irritate, as it's saying here. It can irritate skin and damage eyes. Vapor phase can irritate eyes, nose, throat, and lungs. The storage, handling, and disposal. Packaged in sealed cassettes, as I told you, and indicators change color when exposed to hydrogen peroxide, which I told you the yellow line you see there, at times it could be a white line. And when it's exposed, that line is going to be red. If there's a leakage in the cassette in that plastic container, in that sealed pack. All right. When you're putting it in the machine, you open this pack and then take the cassette from there and put it in the slot in the machine. But whilst it's even here packaged like this, not used yet, if there's a leakage, that yellow line you see there is a chemical indicator that is going to change into red. It could be a white line, it's going to turn to red, meaning that cassette has a leakage. It's of no use. It's no good. And then you have to take all the safety precautions. All right. So always be careful. Don't just take the cassette and place it in. Observe these marks on the cassette. That's what I've said, that when you are there, be very critical of your surrounding, things that are on the walls, things that are inscribed on the papers that you're using, on the pouches. Don't just take a pouch and say, oh, this pouch here is steam, so I just took it for a steam. No. Look at it. What is written on it? Is there an indicator, a chemical indicator on it? Is it steam or is it low temperature? Okay? The same way this cassette, look at it. You see that yellow light is there for a reason. Unlike things that we buy outside, this is a delicate issue, delicate place, a place that we say there's no room for mistakes. As Professor John and Dr. Mike will tell you, don't be callous, okay? Don't be. No room for exposure to any hazard, okay? So make sure you're doing the right thing and observing all this. That yellow mark there is for a reason. So if it turns to red, you don't have to even touch this cassette. Call your manager right away. Okay? Okay. Then when you are handling the canceled cycles, the steroid, as I said, at my end, we try to make it dry before we prepare it for the autoclave. If it goes in wet, a lot of times the system will fail, the cycle will fail. If a cycle fails like that with the hydrogen peroxide, what is it telling you? You must wear your latex or vinyl or nitrile gloves, which are readily available at the SPD. But to be safe, we've told you about the PPE. When you go there, it should be 100% PPE all the time until you get out of there. 100% PPE. Your gloves must be there. I mean, at the clean side, you may need the eye shields, but then for your own safety, like me, I always have mask on me at the SPD, whether I'm in the clean side or whatever. The only thing I take off when I'm leaving the decon, the only thing that changes when I'm between like me being in decon and the clean side is just the facial shield, which is the eye shield, the one that comes with a plate in front, like what people were wearing during the COVID time to protect your eyes. That's the only thing that I don't use when I'm out of the decon. But everything else, I use it. Have the mask all the time. It has become a second nature when as soon as I enter the facility. Okay? And I have the gloves. You see, we have, and at our end, we have the latex and we have the nitrile. You know, we put the latex on and then we put it, when I'm at the decon, I put the nitrile on top of the latex. So it's like two gloves. Because the nitrile is a bit resistant to the sharp, the sharps, the needles and stuff. The latex alone, it may not be enough. So when I'm in the decon, I have those two, which has been very, very good to me in there. Any questions? Okay, so that is one. When it's canceled, you need to have your latex on and follow manufacturer's recommendations and departmental procedures. That's according to what your facility is practicing. All right. OSHA standards and the PPE, you see, it's mentioned right there. It has to be there. Your safety must also be your concern. And then routine maintenance for the machine, that is beyond you, but it has to be done. You should recommend it if it's not being done. Any questions? Okay. So the material compatibility. The compatible materials, medical device and surgical instrument, yes, because that's what we use it for, it's compatible. But then you have to know that, as I said yesterday, some instrument sets will come from the OR to you to the decon. It's going to be processed, washed nicely, go through the washer, come to the clean side, and they're still together because that's how they brought them back there, right? That could be a mistake. They should separate them. If they didn't separate them and it's still in there, it's up to you at the clean side to make sure, oh, this one is for a low temperature, this one's for high temperature. Don't put them together because they came in that same basket. So you're gonna put them in steam. It's not gonna work. You're going to destroy the one that doesn't take heat. All right. So saying that is compatible, you should be specific that this one is hydrogen peroxide compatible or low temperature compatible. If they bring it together from the decon that is cleaned and is here, please put them the way they're supposed to be. Okay? They may have made a mistake back there putting them together. Don't leave it in there. Ask questions. Okay? Ask questions. It doesn't matter how long you are there or how long the other person has been there. Ask questions. We ask questions every day. And there is always a learning process because every time there are new instruments coming, complicated instruments coming in, and everybody's learning every day. All right? So don't be shy asking questions there. Ask questions. Poke people for questions, for answers. All right? So that you see the things include the flexible endoscopes, which I know when you go there, you see. That's what I do a lot at the when I went on vacation and we had a new recruit who came in. So he said that anytime that they brought those endoscopes to the clean side, they would start saying, oh, if Charles was here, this would go quick. If Charles was here, this would go quick. So he hadn't seen me because he came in when I was on vacation. So when I came, and then he didn't say anything to me, but he realized that as soon as those things come there and I'm on in the clean side, they don't stay for long. They go and they never fail. He said, "Oh, now I realize why they were always saying, oh, if Charles was here, if Charles was here." And I said, "What happened?" He said, "Anytime these things came, they'll say, oh, if Charles was here, we wouldn't have to worry about this." And so you see, that is it. So when you go try to do some things like that, so that you will be remembered when you are not there. They say, oh, he's a specialist in this field. If he's here, this thing is not going to happen. Just do it. But the point is, these flexible endoscopes are a bit, how should I say? As I said, they should be crisp, dry to put them in these sterilizers. You see, so some don't get the time to do it, and it keeps failing. So I said, when I went there, I saw that no, this was how I was trained. It's supposed to be crisp, clean, and dried. So I said, no, guys, look at this way. We're gonna do it this way. It's gonna work. My manager said, okay, try it. We tried it, and since that time, we don't get failed with anymore. The only time to fail is if somebody who didn't know the culture that we have actually made there goes and puts something wet in the machine. But even that, we keep it dry after a while and it wets since we know how it operates. Okay. And that's why you are being trained here. You know how the thing operates. If there's a slight skirmish here and there, you should be able to rectify it. Like, oh, it's because of this wet thing. Next time, let's dry it. It's the low temperature. It doesn't need steam in there. So we don't need water to create any steam in there. It's simple logic. It doesn't take steam. So why would we leave water in there? And remember, the machine takes water out. So if it's too much water and it's not able to take all, definitely the low temperature sterilization is going to fail. All right. So things that it takes include rigid scopes, which you see when you get there. I think Professor John told you about rigid scopes and the flexible ones, yeah, and the semi or semi-flexible ones. So you know those cameras and light cords. They're all the light cords. He told you about. They're difficult to actually check for their viability, but this trick that we use is usually we point one side to the light and look at the other side. If the light reflects through it, it's good. The cords are good because they are more like fiber optic cords. All right, that's a trick that we use there to see it. All right, but there are machines, there are equipment that we can use to test them too. Okay, so the incompatible ones, it says batteries and power drills. Those are also able to go into the hydrogen peroxide machines. We have those Baja drills, we have the micro drills, we have a lot of drills there. The drills are able to go in there. Have the endotine and the rest, they're all drills, they're able to go in there if they actually fall in line with the IFU, because our endotine goes in for steam and it's still good. All right. So depending on the IFU that they give you. So The incompatible materials include liquids and powders. And I think so far we've been seeing this on over and over in sterilization, that liquids and powders are one of the incompatible things, both sides. All right? Materials that absorb liquids, this one can take it. Hydrogen peroxide will not take it at all. Items containing cellulose, example, cotton, paper, cardboard, it can take it. Linens, hot towels, gauze, sponges, it can take it. Because even with the steam, sometimes when we don't have those liners that we put in the trays, the silicone mats, if you don't have them, at times we put other liners in there. But this hydrogen peroxide will not take those liners, because if they are cotton or paper or anything, it's not going to take it. So you're better off leaving it as it is in the container, or putting what the IFU tells you should go in, maybe the silicone mat or something. Other than that, don't put anything there to generate any trouble. All right? Well, these are materials that it wouldn't take. Materials that absorb liquid, it wouldn't take it. Linens, it wouldn't take it. And since you don't want trouble and you're not going to be sure of these things, when you go, the way it's treated, if it's silicone mat in the camera tray, leave it as it is, dry it and put it in there. Don't change it without telling anybody anything. If it doesn't have it, talk to your supervisor, okay? Don't do anything on your own accord. Talk to your supervisor or consult the IFU. Any questions? It looks like this is a revision, so you guys are good. The packaging is what is the importance of packaging this material? It affects the penetration. We said how you arrange the instruments in there. There was a time a camera went into our hydrogen peroxide thing, sterilizer, and failed. The guy was new though. So I told him, it was just me and him. I told him, come, open it. Let me show you something. So I was actually preparing one. So I said, come, let me show you something. He took it out. We opened it, and he looked at it and looked at mine, the one that I was preparing. He said, oh, now I know why it failed. And I said, why did it fail? He said, we arranged it in there. So I said, okay, that's it. That's all I wanted you to know. And because it was just why it failed. He didn't look at how he put the thing. He just crumpled the cords, which is the camera cord itself, and then the additional light cord. He just crumpled them, anything, anywhere, forced it into the tray, the basket, and then just put it in the canister and put his locks on and scan it, put his indicator and scan it, and put it in. So he said he looked at it and saw his fault. He said, oh, that is why it failed. Because he didn't understand. He told me he didn't understand why I always did it the way I did. Because even when I'm in the decon and I do cameras and they come to the clean side, they come in a special way. They're already well organized by the time they get to the clean side. So when they are dry, all you do is add your indicator and it's good to process it for sterilization. So now he understood why I organized it that way for penetration. Okay? So there are certain things you will learn on the job. The book is not going to tell you you're lucky you have experienced people telling you all this, but when you go there, you're going to learn more too. Okay? You may meet people who are very good teachers who get you like going as soon as you get there. But then what we're giving you here, trust me, I've been to other schools, other training centers. This center has the right people that you need, more than you even need, the right people. Okay, you have academicians, you have everything here. We are not disclosing our identities and credentials to you yet, but take it from me. You have the people, okay? So you are ambassadors. You're going to go out there and prove to the world that Charisma is one of the best, and we have the best too, okay? Right. Any questions? So the packaging materials, I told you, everything will be there for you to use. Questions, just ask. Everything will be there. The materials will be there. You don't have to go buy any material. But just know that to see that for the materials that are there to help penetration, for the diffusion of the plasma, everything is set for you. All you do, clean it, sterilize it, clean it, get it here prepared nicely, get it wrapped neatly, arrange it the way you've been trained to arrange it, for penetration, wrap it, put your indicators, and then you are good to go. Every material is supplied there. You have the table, the magnifiers, the lights, everything. Any questions? The incompatible packages include the cellulose containing materials like paper, plastic pouches, which we've mentioned already. The cellulose-based disposable wraps is going to be there. Some hospitals don't even use it. My job, we don't even use those ones. So there's no way I'm going to get it to even put it in there. But whether you know it's that one or not, your hospital is going to provide it, and then ask questions and then use the IFU. Okay? Any questions? I hope you guys are following since you're not asking questions, because this, I said, is more of a revision to you guys. So I'm not surprised you're not asking questions, because this is a complete repetition, just adding new little perks here and there for you. Right? Loading hydrogen peroxide gas plasma sterilizers is the same loading that I've told you. Don't be callous. Make sure you're doing it right. It should be spaced out. The pouches, you know how to place the pouches in the basket, paper to plastic, like that. Like you've been to the library, see the bookshelf thing. That way, put it in there. Forget about what everybody's telling you about. Oh, the edgeway is that style. Okay? So just use that style. Remember that. I know you remember the bookshelf all the time, and use it that way. Okay? Spacious, no overloading, no overcrowding in the canister, and no overloading outside in the autoclave. Be careful, because if the wrapped set comes out with a tear or a perforation, a punch in it, it's of no use. It must be intact all around until it gets to the OR. And that is why you should be careful loading and offloading it. And then storage. If anything tears, punches it, or gets an opening on it, it's of no use. Any question? So proper loading for effective sterilization. Ensure the chamber is not overloaded. Overloading can reduce the available amount of hydrogen peroxide. Reduced hydrogen peroxide can lead to sterilization failure. Hydrogen peroxide reaction and absorption. Hydrogen, it may react or be absorbed before reaching all surfaces, which is something that we don't like. Okay, so proper loading ensures that the hydrogen peroxide reaches all surfaces. Okay, the sterilizer performance monitors, just like the steam one, you have a dashboard there, just like the ETO, but then the parameters on it are going to be different. All right, but then you have physical monitors. You're going to see them right there. All critical parameters are on there. It's telling you this thing should be up to 130. I think that the hydrogen peroxide is 131 degrees, right? That's what I told you. It wasn't cold. It's not supposed to be cold. It's 131 degrees Fahrenheit. If you look at the hydrogen peroxide, the circuit temperature is 131 degrees Fahrenheit, and the time is between 24 to 75. And I said the ones at my job is 49 to 52, at times to 53. Okay, so we at least we are in the medium, the mid range. And then the vacuum level is automatically controlled, and the plasma is automatically controlled. What you have to do with the minimum, to minimize your likelihood of getting exposed to anything in there, you have to always make use of the SDS, which is the safety data sheet. The safety data sheet, right? Always make good use of it. You must, and always wear your PPE, and then especially your gloves. You always have it. That's the only way you can minimize whatever exposure. But these indicators are all monitors. We have the physical, we have the chemical, and we have the biological, as I explained earlier. Okay? The exposure monitoring procedures. You see, the images that they're giving you, I don't think it's not your job to do it though. Your bosses will have to put that on you to help you. This is our exposure monitoring system. You have to put this, to hang this on your chest, and it's going to detect this or take a sample of the air, depending on what machines you're using. So it's telling you the monitoring procedures. Follow manufacturer's instructions for use and adhere to established guidelines. Okay? And then at the operational area, they have to be always conducting monitoring during system operation. You don't conduct monitoring when the system is not working. When it's working, that's where you monitor it. Okay, any questions? All right. The vaporized hydrogen peroxide system. Now we're talking about the vaporized one. Anybody has a question about what we've gone through yet? The exposure monitoring and everything. The loading. I know it's not no new thing to you. The performance monitoring, you see the chemical indicators and everything. The physical, the chemical, and the biological. It's not new to you. Now we take this is another type of the hydrogen peroxide system. This one is the vaporized hydrogen peroxide, which is VHP. All right. It's low temperature sterilization technology available since 2007. It utilizes an oxidative process, just like the hydrogen peroxide, the first one that we spoke about. The efficacy, it uses 59% hydrogen peroxide solution. The other one, which is the hydrogen peroxide, was from 59 to 95. You see the difference now? Mr. Obin, do you see the difference? It's all hydrogen, but one is vaporized, and the vaporized one is saying that it uses 59% hydrogen peroxide solution. And the original one that we spoke of uses between 59 to 95%. Okay, so if there's any difference, that's where the difference is showing up. The vaporized use 59%. The regular one uses between 59 to 95. Effective against broad spectrum of pathogens. Good. The penetration, it is injected 4 times during each cycle, which is the vaporized one. It is injected 4 times. The other one is injected, but they didn't specify the times. But this one is injected 4 times during each cycle. Converted to water and oxygen through a catalytic converter. Okay? So that converter actually converts the vaporized hydrogen into water and oxygen. So the peroxide systems, we have 2 types of the vaporized hydrogen peroxide sterilizers. There are 2 types of that which you don't need to know. You just need to know, but you don't need to work on that because your department or the facility has what it has for you. If it has those ones, you're surely going to work with them and you're going to see the types. All right. Sterilization cycle and process parameters are all there. The temperature, as I told you, it's around 131. So they're going to have the parameters for you there. You are not going to set it. It's going to be there for you. And especially when you process an instrument, the sticker or the label you put on comes with the parameters on it. Your name, the date and time you process it, the parameters, the name of the instrument, and the parameters on the sticker. So even if you don't know anything, look at the parameter that was printed out and then use that. Okay? And when we talk about the parameters, don't be confused. You see the screen that you see there on the picture? The parameters are going to be written there. It's about the temperature, the exposure time, and then the dry time. Those are the parameters. They are like measurements. All right? So they keep talking of parameters. Everything with meters on it tells you it's a measurement. It's a measurement of something. So the parameters for this, as we keep talking, is the temperature, the exposure time, which is the diffusion time or the penetration, and then the dry time. Okay? And that's all. So based on that, you select what you're doing and what is instrument you are cooking or sterilizing, and then use that. If it's the IFE tells you this instrument goes for 275, look for the cycle that says 275, 4 minutes exposure, and then 10 minutes dry time. Fine. If that is it, put it. If it's an implant, it will tell you 270 degrees, and then 4 minutes exposure, and instead of the 30 minutes dry time, you're going to see another 40 minutes dry time. So instead of the 270, 430, you see the parameters will say 270, 440. Okay? It's not rocket science. When you go there, you see it. It's as simple as I'm telling you. So the background of this VHP is a low temperature method. It utilizes vaporized hydrogen peroxide as against the one that uses the hydrogen peroxide. Okay? This one utilizes the vaporized one, and it's available in U.S. hospitals. I don't know about other countries, but I know U.S. hospitals have it. Introduced since 2007, widely adopted for sterilization purposes. Any questions? Any question? its efficacy. It's effective against a broad spectrum of pathogens, just like the hydrogen peroxide, because this is just the vaporized one. It includes spores and bacteria. It kills spores and bacteria. You know, spores are very difficult to kill. All right. It targets microbacteria and non-enveloped viruses. Effective on enveloped viruses and cysts. Like what Dr. What Mr. John will say, naked. It's supposed to be naked viruses, right? These are not naked, these are dressed viruses. They are enveloped viruses. They are not naked. But then it's able to kill them even in the envelopes, right? Good. So that is the difference. It's able to kill them even when they are non-enveloped or they are enveloped. All right. So when we say something is enveloped, it's within another thing. Like you mail a letter, you put a letter in an envelope and seal it. That's how this bacteria, it's within an envelope, it's within a seal. But then the effectiveness of the vaporized hydrogen is telling us that it's able to kill such enveloped viruses and cysts. Okay. It also works on fungi and protozoa. Uses a 5996 hydrogen peroxide solution. Ensures thorough sterilization. So the 5996, I think we will have to decipher that. But I think it's just the range for the hydrogen peroxide. But they told you that even the 59 is still good, while the original one ranges from 59 to 95. Okay? It ensures thorough sterilization. Any questions? The penetration, which is the exposure or the diffusion, okay? The injection of vaporized hydrogen peroxide, it's injected 4 times during sterilization cycle. Aeration process, automatic aeration after the 4th injection. So after the 4th injection, the things have been, the instruments have been exposed already to they've had the exposure that they require. So then the machine injects after the 4th injection, it injects the air in there. Okay, the aeration process takes place to get rid of whatever gases are left on there. And that's why I said it's not cold air that comes in; it's warm air that comes in. All right. Okay. So then the exhaust phase comes in, where the exhausted, the VHP system is exhausted through catalytic converter, turning whatever is in there into hydrogen and it said water and oxygen, right? Yeah. So the converter transforms the VHP to water and oxygen. That's good news. So nothing bad coming out. Talking of the types of it, types of vaporized hydrogen peroxide systems, which you don't need, but the point is you just need to know about it. They have the single cycle system, the dual cycle system, and the manufacturer's guidelines is the primary thing for you. Whether you're using the single system, it's pre-programmed for 55 minutes, used for both lumen and non-lumen instruments. The dual cycle is 2 programmable, like program cycles on the 28 cycle and then the 55 cycle. It's up to you when you get to your job, and that's what they have. That's it. Don't be surprised that one has 2 cycles and one has 1. But above all, you need your manufacturer's guidelines, the IFU. The cycle and process parameters, it's set already. Okay? But what you know is, I told you this one was around 131 degrees Fahrenheit. Compared to the steam, which is 270 degrees Fahrenheit, this one operates at low pressure and low temperature. The higher the pressure, the higher the temperature, right? The higher the temperature, the higher the pressure. This one is low pressure and low temperature. That's what I told you, around 131, which is low compared to the 270 that we use for steam. Suitable for heat and moisture sensitive medical devices. Instruments that require more than 150 will go to the other one. Those that require less than 100 and less than the 130 should be good in here, or slightly above 130, they should be good in here. Those that cannot take the 270, because if something requires like 150 and put it in the 270, it's a no. Right. So those that are sensitive, that cannot take the 270 Fahrenheit, but can take 130 Fahrenheit, we give it to the low temperature sterilizer to take care of that. And a vaporized hydrogen peroxide can do that. Okay? And this is how it generates it. It injects aqueous hydrogen peroxide into a vaporizer chamber. So when it injects it into it, it's going to create the vapor from there, right? So the solution heated converts to vapor, and then it is introduced into the sterilizer chamber at the pressure. Any question? Hello? Okay. So, is there any question about what I just said? All right. So that's how it generates the vapor. Okay. And then the phase is just like what we did before. It goes through the conditioning where it removes the air and excess moisture. It goes to the leak test where if there is a leak, it's rather going to suck air from outside into it instead of releasing air from it out to come out. Okay. And then the sterilization. So the safety measures are just the same. Hazards of hydrogen peroxide is corrosive to the skin, eyes, nose, throat, lungs, and gastrointestinal tract. The normal use conditions, operator not exposed to sterilant container contents. That is what I told you. Because if the cassette that you saw there with the yellow condition, the yellow indicator on it is still yellow, when you open it, you are not exposed to it. When it's red, you don't have to open it because you'll be exposed. But remember, these are all uh, engineering efforts that we've made to this point, such that we personnel don't get exposed to these things. All right. So the normal conditions, you are not exposed to the sterilite if everything works right. The sterilizer automatically dispenses and injects the liquid hydrogen peroxide. The hydrogen peroxide vapor converted to water and oxygen at the end. Aeration phase removes residuals from the instruments, so we don't have to even worry too much. But handling when it's the situation when the system didn't get to the end and it was cancelled, that's where you have to be extra careful, and that's where we always insisting wear the gloves before you touch those instruments that you're taking off out of a cancelled cycle or a failed cycle. The employee instructions are there, hazards of hydrogen peroxide and applicable SDS, okay, which is the safety data sheets. Look at those things. I've told you, read everything that you can lay hands on over there at the job. Read everything you can lay hands on. It's good. It's good for your safety and for the safety of your co-workers. Any questions? Exposure monitoring, that is the job of the directors and your management. But then this one doesn't even need personal monitors. It doesn't need them. No personal monitors needed. Because look at the end result. What is bringing out is oxygen and what? So we don't need anything that's not that safe. The aeration takes care of the residue, so you are not that exposed. But then remember, there could be failed circles where you need the gloves, where we should think of maybe some little exposure. But then there is no exposure there. But we are saying that protect yourself, use the gloves before you touch those instruments. But then at the end, the aeration takes care of the residue, so it doesn't need like personal monitors. No area monitors required. The testing results, hydrogen peroxide vapor levels are always tested. And then the acceptable levels are always found. Testing conducted during typical sterilization cycles. That is what you go to meet at the job, and then they have to follow it, and you have to also obey whatever it's there and follow it. Material compatibility. Compatible with various medical instruments, just that the original hydrogen includes telescopes, cameras, light cables, batteries, and lumen devices. Evaluations ensure safety because they always have to evaluate this machine. How often? That's why we document everything. How often is it failing? How often is it passing? How many instruments is it taking in capacity? You have to take all that in consideration. Correct cycle selection is also crucial. All right? Not intended for liquids, as usual, linens, powders, or cellulose materials. The packaging materials, the way you package it, you know it as at now, it affects sterilization. No matter what machine that you are using, your packaging is going to affect sterilization. Okay? So try not to do the wrong thing. We've told you a lot about how to package it. No overcrowding, no overloading. Make sure heavy items go down and the light ones on top of them to ensure that there's complete penetration and exposure. All right. Approved materials, including the polyweb, all these things, and the T-back you see when you go to the job. They are special materials that we use there, special wraps that we use there. So when you go, you see them. All right. They are not on the market just anywhere to find them, but then they are specially there for you. They are the polyweb is non-woven. Okay, it's non-woven sterilization packaging made of the polypropylene. The polypropylene. Okay, it's non-woven. But when you go, you see it, you hold it, test it, you see the texture of it. That's why I'm saying that when you go, you have to learn everything there, observe everything there, look at every details, test it, look at it, and ask questions. Why is it like that? Why is it two attached together? You have to look at it, okay, and ask questions. Trays and organizers from the manufacturer allow gas penetration. So you should know that what tray that you're using should allow gas penetration. If you don't understand the mechanism of that tray, the makeup of it, and you think that it's not the right thing, ask questions. They'll tell you why they're using it. Or maybe it's a mistake that is there and they'll change it and give you one that is actually going to help allow gas penetration. Okay? And whether the thing is compatible with the VHP process. Any questions? So look at the image here. This is like more of a tabletop sterilizer. You see how the instruments are in there. He put the wrapped one on top and the canister one at the bottom. Who can tell me why? Who can tell me why it's like that? Mr. Obin, I'm on YouTube, Mr. Otin. Do you have any idea why it's like that? Or Amina, is Amina around? I think Amina. Shania there?
Yeah.
Why do you think it's like that? Do you see the image?
Yeah, maybe so the water don't get on top of the cloth.
On top of on top of the wrap. That's one reason, because a lot of times, from practical experience, right? Some of the other clips, when you put the canister on top and put the wrapped one at the bottom, during the process, the bottom one is going to get water dropping on it from this canister. All right. But remember, this canister is not going to absorb any water during the process. Okay. This one, the one on top, it's material. It's a woven material. It's a non-woven material, but then it's not a metal. So at times when that happens, you could see the water dropping onto this when the wrapped one is underneath it. And secondly, the wrapped one is less heavier than the one in the bottom. You see, the one in the bottom is bigger, right? So, but a lot of times what I do is I said during the steam sterilization that look, when you go, to be easy on you. If you're doing only canisters, do only canisters. If you're doing wraps, do only wraps. Okay? So if there were two canisters, you could put a canister on top, a canister at the bottom. You are safe. If there were two wrapped instruments, you could put one wrapped up, wrapped down, you are safe. Okay? But when you have to do them at the same time, try to do the lighter ones or the wrapped one on top and then the canister in the bottom. Okay? And also remember, avoid overloading. Avoid overloading. Avoid it. You see how it's in the one. There should be there's space on the side that maybe you could squeeze something there. But is it necessary? No. Because we've told you avoid the walls. All right? So if whatever you're going to squeeze there is going to be touching the walls, it's of no use. So avoid overloading. Any questions? The loading is also the same thing. We got to have the physical monitors and the chemical indicators and the biological indicators. You have to make use of them. There's nothing like a load being sterilized without any physical, chemical, or biological indicator. There's nothing like that. That is the only way you can measure your sterility. That's the only way you can measure the performance of the sterilizer. So there is no way you're going to go through a sterilization process without these chemical indicators or biological or physical monitors. Okay? So that's just a revision. Now the next one is the ozone sterilization. I told you there were three: the ethylene, the hydrogen, and then the ozone. The hydrogen we had two, which was the regular hydrogen, and then the vaporized hydrogen. Now the last one is the ozone sterilization. Okay? It's a contact sterilant with penetration limitations similar to hydrogen peroxide. All right. I don't know, for some reason, I don't like ozone sterilization. I don't know why, but just for some reason, it doesn't appeal to me. But it looks like it has a lot of good sides too. Okay. So restrictions related to size and length of lumens, this is going to be by the IFU. It has some restrictions to certain things that can go in, like channeled instruments, okay? Instruments with holes, with canals in them. The cycle and process, it has 4-hour cycle with vacuum, humidification, and ozone injection phases. 4-hour cycle. Maybe that is why I don't like it. 4 hours. Okay, you're going to work for 8 hours, which means that if you start, as soon as you go in, if you push in a load for ozone, the only thing you can do is just one load per day. Because after 4 hours, it has to cool down. There should be aeration before it comes out. You can push in the second load. Because who is going to take the second load out when you are out of the place? Okay? So maybe that's why I don't like it, but I don't know. I just, it doesn't appeal to me. But it has its good side, as I said. If it's the best for your situation, you got no choice but to use it and get used to it. So look at it this way. It says that 4-hour cycle with vacuum, humidification, and ozone injection phases. Critical process parameters monitored and printed, just like all the other sterilizers. Cycle aborts if parameters are not met, which is a good thing. If the parameters are not met, if it's supposed to be 275 by 10 by 30, and then you go and put maybe 275 by 10 by 40, it won't take it. Or if it doesn't reach that, it's going to abort it, especially if the machine in the first 2 cycles is not able to reach the 270 peak of it for the exposure phase. If it doesn't reach, it's going to abort it. Because if it even exposes them to it, it's not going to work because it needs 270 and it's not getting the 270 heated up to the 270. All right? So it will abort it, which is a very good thing. Safety and regulations. Ozone is toxic and regulated by OSHA, FDA, and NIOSH. NIOSH and OSHA, they're almost the same. This one is, right, the NI for the second one is National Institute, okay? And then we have OSHA, which is Occupational Safety. Okay, so operators must demonstrate competency. You must be well versed with the ozone system to work on it, with the ozone sterilizer to work with it. You must demonstrate it because the way it is 4-hour cycle and stuff, you really need to be well versed with it. All right. The material compatibility too is there. You have to use the IFU, loading and performance monitoring, just as the other claims. You have to look at all the parameters, look at everything that is supposed to be in there, what temperatures, and how long it's supposed to be in there. The penetration is a key. Ozone sterilant characteristics, contact sterilant. Okay, similar process to other low temperature sterilization methods. Reactivity and penetration, highly reactive. Penetration limitations similar to hydrogen peroxide. So it looks like with the difference in the time, the cycle of 4 hours, a lot of things are similar to the hydrogen peroxide one. Okay, the restrictions and recommendations, size and length of lumens. There are certain things that don't have to go in there. If a lumen is beyond certain diameter, it's not supposed to go there. It won't do good in there. So you have to follow the sterilizers and device IFUs, all right, from the manufacturers, which is something that we keep talking over and over. All right, the cycle and process, the overview of the sterilization cycle, the 4 hours is still here. Cycle duration is 4 hours. Ozone cycle duration is 4 hours. Begins with loading items into the chamber and closing the door. Then the vacuum is drawn. Then humidification phase follows. Then the ozone injection and repetition comes in, where the ozone is injected into the chamber. Then the steps are repeated. So you see the first cycle of the loading and then the vacuum drawn and the humidification phase. If the humidification is not up to the percentage that it wants, that's where it's going to abort this load. And aborting the load is about canceling the load. It's going to cancel the load. We say it's aborted. It canceled the load. It is aborted. So it's going to reverse everything, and then you have to take the instruments out again and reprocess. All right? So these are the steps that is going to go through. Then the ozone is injected, and then steps are repeated again. And then the final ventilation phase, where it removes the ozone from the chamber and packaging. Okay, it also has control and monitoring. The safety measures, OSHA regulations and competency requirements. We told you about the OSHA, okay? The occupational safety and hazards. That authority is always in the workers' interest. Let me say not all, but mostly in the workers' interest. They want to make sure anything that is a hazard on your job, there should be there should be a safety measure, and that is the responsibility of the facility management. And they come around, they make surprise visits and surveys to make sure these things are in place, to make sure the organizations are following the PPEs and all the protective and safety measures that will keep workers safe. Okay, so they make surprise visits. You see them; they will come a lot of times when you are on the job. They'll ask you questions. Feel free to answer questions as they are. All right, because it's about your safety and your colleagues and also the patient care. Cycle parameters, the temperatures, 87.4 to 97%. So you see why it's a low temperature sterilization process? 87.4 degrees Fahrenheit to 97 degrees Fahrenheit. It's not even up to the hydrogen peroxide, which is 131. Okay? And then the ozone concentration is 0.59%. 0.59%. Relative humidity is 856 to 1006. But this, it didn't put percentage or anything, but it says the relative humidity. As it's so relative means it's going to go by the percentage of instruments in there, the load in there. All right? And then the time is 4 hours, 30 minutes. Even the 4 hours was annoying. Now it is 30 more minutes. 4 hours, 30 minutes. Okay? So the ozone characteristics and regulations, ozone is written as a 03, right? It's a blush gas with a pungent odor. I think Professor John told you about it, that the smell is something that you can take. Odor threshold for humans is 0.003 to 0.01 ppm, which is the mode of the measurement. All right? So ozone sterilizer design and safety features are there to help to actually make sure this odors and stuff don't come out easily. Okay? The engineering said that you are protected in a way, but then there should always be some kind of monitoring for everything, leakage or anything. So the engineers have found ways and means to make it safer for us to use. But then there are employee instructions to minimize ozone risks. Any questions? Okay. So now it's talking about the materials compatibility, things that are supposed to go in there. Okay. Most of the time, I want to talk about the incompatible ones. The incompatible ones, it said not recommended for sealed ampoules, liquids, natural rubber, latex. You see all those things? Implants, sterilization not ventilated. Implants cannot even go there. So what I was telling you that we have implants at our site for mid-face and other surgery, they can't go into the ozone sterilizer. It can't go in there. So it means that my job cannot use the ozone sterilizer. If we can use it, it's going to be for just a few cases, which may not be cost effective for us. All right. So if there's a hospital that is doing a lot of implants, it means the ozone it's not good for you because it's not going to take, it's not validated for implant sterilization. Okay. Packaging recommendations: use specific wraps, peel pouches, and rigid anodized aluminum containers, which is good. We have it at our end, but we do implants which are not validated for it. So you see how all these things have to come into play to know what sterilizer to use. Verify other forms of packaging before use. Woven fabric, metal foils, and hermetically sealed packs are inappropriate. You see that? So that this is why the IFU is the sole document to be always looking at when you're doing these things. Look at the kind of things the machine doesn't take. So you have to look at all this and make sure you don't put them in an ozone in case there's an ozone sterilizer at your job. follow manufacturer's instructions. Always adhere to device manufacturer's recommendations. If it's not recommended, don't do it. Any questions? All right, the packaging, the same thing. Proper loading, don't overload. That's the same thing that's being repeated. So your loading should be something that you have to always make sure you're doing it right. The performance monitors are always going to be there. The physical, chemical, and biological indicators, they're always going to be there for you to use. Then the review of low temperature sterilization processes. The ethylene oxide penetrates medical packaging and device lumens. Compatible with most medical materials. Simple to operate and monitor. That's the ETO, okay? Toxic, flammable, carcinogenic, and mutagenic, okay? You see that what I was telling you, that the carcinogens, even carcinogens, you can get them from cigarettes anyway. It's not like too crazy to think about. Even cigarettes can cause cancer. So any carcinogen is a cancer-causing agent. So don't be scared that ETO has cancer-causing agents. Even cigarettes can cause cancer. All right? Okay, that's by the way. All right, so look at it. This is just a review, and I want you to look at this slide very well. If you could take note of it. It's a summary of all three. All right? Then it tells you that the ETO requires lengthy aeration, 8 to 12 hours. 8 to 12 hours for aeration to take place, okay, and requires personal and area monitoring. So looking at it this way, looking at the time and everything, you could determine if you need it or you think your job needs to use this, depending on what instruments you're using and the IFU. The time is maybe going to be the last thing you consider. If it's your last option, you have no choice but to use it for low temperature sterilization. But that is not in your court. It's in your manager's court. All right. Then the hydrogen peroxide, the H2O2. In practical terms, when you're writing, the 2 is written below the H, and then the 2 after the O is also written below the O, okay? All right, the gas plasma. It's safe for the environment. It leaves negligible toxic residue, which is very good, all right? But then, looking at all this, the ETO, the vapor, and the ozone, I said 4 hours. Look at the ETO needs 8 to 12 hours for aeration. So you see that time is a factor in here. And that will tell you why most hospitals don't have the ETO or the ozone. Everybody thinks of rapidity in this kind of processes. So it makes like the low temperature sterilization, it makes the hydrogen peroxide becomes more like demanded than the other ones because it gives you a rapid cycle. The end result or the byproducts are not harmful, they're not toxic. But then it's my opinion though. You have your own opinion about time and all those toxicity. But it's my opinion. If I'm evaluating the 3, I think that will be my best choice. But depending on the hospital, the facility, the rapidity of the turnover of instruments and all that. Okay. So that is up to the directorate to take care of that. In conclusion, I think modern instrumentation complexity has brought about all this. Okay, more sophisticated and complex than past devices. So we have to be sophisticated in treating them and handling them and sterilizing them. Okay, materials often cannot withstand high temperatures or moisture. So we need a low temperature sterilization. And then the safety for patients when procedures are carefully followed is why we are going through this training. If we follow the procedures carefully, our patients will be safe and we will be safe too. All right, and our job will be done. Safe for medical devices and central service technicians. This is why we are going through this. Any questions? Any questions from anybody?
No.
Is everything well understood?
Yes.
So now we've done the
Yes.
steam sterilization, we've done the low
Yes.
temperature, which you're going to see when you go to the field. But then you don't have to be scared because we've given you everything about it. Everything at the hospital is what your facility wants to use. Ask questions, read everything that you can lay hands on there. notices everything. All right? And that way you get used to everything in there as soon as possible. And with your training, you will be on top. Okay? So if there are no questions, I think we were going to end here today. We have done good. We've exhausted our slides in good time. I'm not sure if were you guys able to get access to the test after yesterday's class.
I'm not able to access the tests in chapter 9.
Oh, okay, hold on. That director will take care of that, but you know he's out for a little bit. But don't worry about it. Just get used to the notes that we have, and you have the textbook, right?
Yes.
Yeah, just get used to that. We'll do the backup. If you need backup, we'll give you a backup. Okay.
Okay.
So anybody in that situation, don't worry too much. If you need a backup, we will find a way for you to get a backup. We are up to making you as the professionals that we want, and we are always standing in your place wherever we go, saying that we're bringing out the best. So don't worry. Any lapses as at now, we'll catch up with it and we'll get you to where you want to get to. Okay.
Okay. Thank you.
All right. So without any questions, I think we're gonna end it this way, and then
Professor,
uh-huh.
yeah, a quick question. This is regarding the internship. I just want to ask, how many hours is it gonna be like every day? Is it gonna be like 8 hours in 5 days, or like how long?
Actually, it's a good question that you asked. This is for all of us. I actually went to the meeting too. They told us that okay, they have 8 hours because remember the thing is 400 hours in total.
Yes.
So we said okay, if we can get 8 hours a day for people that can come 5 days a week, that means they are good. But then we talked of most of you are also workers and fathers and mothers. So a lot of times your time it may not be that convenient. So between director and we here, we're gonna find a way to see if we could get several schedules to accommodate those things. But under normal circumstances, it could be like the 8 hours for 5 days a week to get it done. Okay?
Okay, yeah. I feel that would be good because 400 hours with like 10 weeks
10
or
weeks,
so.
yeah.
So
So
we
that
need
is
that
how
eight
we worked it
hours.
out. 8 hours for 5 days a week, it's good. But then we're trying to accommodate everybody so that we can get other flexible schedules. But I think the best and ideal would have been the 5 for 8 hours, which will get you out as soon as possible. All right.
All right. Thank you.
So anyone that has issues with it, text it to director because we'll be discussing on it to find a way to accommodate everybody's situation the best that we can. Because remember, a lot of them, we just have to plead with the other authorities. So basically, what they gave us was the 5 days, 8 hours a day for 5 days, which we ideally agreed to. Okay. So those that want that, you should be fine. But those that need some accommodation, we will think about it when director gets back and plan on how to deal with that. Any more questions? All right. Without any more questions, we'll bring it to an end until next week. Okay.
Okay, thank
Have
you.
a great week and stay up with your notes and the textbook.
Okay, thank you.
All right, bye.
All right, thank you, Professor.
You're welcome.